Welcome to the DEFCAM. Pakistan Air Force's retaliatory strategy during the initial skirmish of Operation Sindoor, a hypothetical military engagement following Indian Air Force incursions into Pakistani airspace, was defined by the integrated deployment of advanced air-to-air munitions and layered air defense systems. Central to this response was the utilization of the PL-15 Beyond Visual Range air-to-air missile and the HQ-9B Long-Range Surface-to-Air Missile System, which together formed a multi-tiered defensive network capable of neutralizing high-value aerial threats. This technical and operational synergy enabled the Pakistan Air Force to intercept and destroy 5 Indian fighter aircraft, underscoring the efficacy of modernized aerial warfare tactics in a contested environment. The PL-15, developed by China's Luoyang Electro-Optical Technology Institute, is a radar-guided air-to-air missile designed for engagements at extended ranges. Its active electronically scanned array seeker, paired with a dual-pulse solid propellant rocket motor, enables terminal-stage target tracking independent of the launch platform's radar. The missile's maximum engagement range of approximately 145 kilometers allows Pakistan Air Force pilots to engage hostile aircraft before entering the adversary's weapon release envelope. This capability is particularly critical against Indian Air Force assets like the Rafale, which employ the Meteor missile with a comparable range but rely on continuous radar illumination from the launch aircraft. Complementing the PL-15 is the HQ-9B, a surface-to-air missile system optimized for high-altitude interception. The HQ-9B's passive phased array radar provides 360-degree coverage, detecting airborne targets at distances exceeding 250 kilometers. Each battery consists of 8 transporter erector launcher vehicles, with missiles capable of engaging multiple targets simultaneously using inertial guidance mid-course updates and terminal active radar homing. The system's ability to integrate data from airborne early warning platforms, such as Pakistan's Karakoram Eagle aircraft, enhances its accuracy against low observable threats, including stealth-modified fighters or cruise missiles. The Pakistan Air Force's retaliation was predicated on real-time sensor fusion across airborne and ground-based platforms. Prior to the skirmish, the Karakoram Eagle Airborne Early Warning and Control System, equipped with a mechanically scanned array radar, detected inbound Indian Air Force formations over the Rajasthan desert. The radar's operating frequency in the ultra-high frequency band allowed it to penetrate electronic countermeasures, identifying Rafale and Su-30 Mki fighters via their radar cross-section signatures. This data was relayed to ground control centers and disseminated to interceptor squadrons and air defense units via secure data links. Pakistan Air Force JF-17 Thunder Block 3 fighters, armed with PL-15 missiles, were scrambled from forward operating bases near Bahawalpur and Sukkot. The JF-17's KLJ-7A active electronically scanned array radar, operating in the X-band, provided continuous tracking of Indian aircraft while maintaining a low probability of intercept through frequency-agile waveforms. As the Indian fighters approached the border, JF-17 pilots initiated lock-on procedures, exploiting the PL-15's active seeker to maintain target illumination even if the host aircraft retreated. This tactic, known as launch and leave, allowed Pakistani pilots to disengage after missile launch, minimizing exposure to Indian counterattacks. Simultaneously, HQ-9B batteries deployed near Multan and Rahim Yarkhan activated their engagement sequences. The system's fire control radar, operating in the S-band, discriminated between incoming fighters and decoys by analyzing Doppler shift patterns and radar cross-section fluctuations. Upon confirming hostile intent, the HQ-9B's command and control module assigned priority targets based on speed, altitude, and trajectory. The missile's thrust vectoring control system enabled rapid course corrections during the boost phase, ensuring interception within the calculated kill zone. The Indian Air Force's initial strike package included 2 Rafale fighters armed with Scalp EG cruise missiles, 2 Su-30 Mkis providing electronic warfare support, and a single Mirage 2005 for reconnaissance. The Rafales, flying at an altitude of 12,000 meters, attempted to jam Pakistani radars using their Spectra electronic warfare suite, which employs digital radio frequency memory techniques to generate false targets. However, the HQ-9B's frequency hopping capability and the JF-17's radar warning receivers, integrated with Turkish Aselsan ALQ-178V3 jamming pots, mitigated these effects by dynamically adjusting emission frequencies and polarization. As the PL-15 missiles entered their terminal phase, the active seekers acquired the Rafale's radar returns, overriding Indian chaff dispensers through high-resolution range gating. The first Rafale was struck at a distance of 80 kilometers, with the missile's 22-kilogram high-explosive fragmentation warhead detonating within 10 meters of the target, severing its vertical stabilizer. The second Rafale, executing a defensive spiral maneuver, was intercepted by an HQ-9B missile that exploited its reduced kinematic energy during the evasive turn. The Su-30 MKIs, operating in a standoff jamming role, were targeted by a combination of PL-15s and ground-based electronic attacks. Pakistani cyber command units, leveraging prepositioned malware in Indian communication satellites, degraded the Su-30's data links, forcing them to rely on inertial navigation. This vulnerability was exploited by a JF-17 section, which launched PL-15s in a pincer formation, overwhelming the Su-30's infrared countermeasures and radar warning receivers. The downing of 5 Indian aircraft comprising 2 Rafales, 2 Su-30 MKIs, and 1 Mirage 2005 demonstrated the Pakistan Air Force's capacity to integrate heterogeneous systems into a cohesive defense network. The PL-15's performance validated its role as a force multiplier in beyond visual range combat, while the HQ-9B's layered interception capabilities provided redundancy against saturation attacks. However, the engagement also revealed vulnerabilities. The Mirage 2005, operating at low altitude with its synthetic aperture radar deactivated, penetrated Pakistani airspace undetected until visual identification by ground observers. This lapse underscored the limitations of radar-based detection against terrain masking tactics and highlighted the need for augmented electro-optical surveillance networks. In response, the Pakistan Air Force has accelerated the deployment of airborne infrared search and track systems on its JF-17 fleet, complementing radar-based tracking with passive thermal detection. Additionally, upgrades to the HQ-9B's signal processing algorithms, incorporating machine learning for threat prioritization, aim to reduce false alarms during high-intensity conflicts. The strategic success of this retaliation hinges on maintaining technological parity with India's evolving capabilities, particularly the induction of S-400 air defense systems and hypersonic missile prototypes. By sustaining investments in sensor fusion, electronic warfare resilience, and decentralized command structures, the Pakistan Air Force aims to deter future incursions while navigating the precarious balance of power in South Asia's contested skies. Thanks for watching. Stay tuned for the upcoming videos.